Okay, so we've been talking about signed numbers. We did adding and subtracting signed numbers, and now we're going to do multiplication of signed numbers, or multiplication integers with signed numbers, and we're going to see some rules about how this is going to work. So multiplication of integers can be presented in a number of ways. In whole numbers, we saw multiplication problems that look like this, or over here. I'll just hang on a second, I'm going to get my pen. Look like this: 2 times 4 equals 8. In integers, multiplication presents itself in a variety of formats. Multiplication sign can be like this. It's kind of important. Multiplication sign can be like that, looking like an X. It can be easily confused with X variable. When I personally use that, I use multiplication sign looking like this. Multiplication sign, I use just an X. But from a variable, I use a different shape of X. Also, multiplication can be shown as just simply a dot, or it can be shown as brackets. Oops, like this. So that means, let's have a look at that closer, because there's many different ways of doing it. Give me an example. So it can be written like this. It can be written as, it's not bad. Using the X format, it can be written like this. 2 times 3 equals 6. Using the dot format, it can be written as 2 with a dot, 3, and give you 6. In the bracket format, you can just go, I'll just again, make it more confusing. There's 2 ways we can do that. We can go 2 bracket 3 equals 6, or we can go bracket 2 bracket 3 equals 6, and all these examples are how we can show multiplication. And the thing is that when I'm doing it, I will flip-flop back and forth from the X to brackets to dots. So you need to know which one is which, and you need to know that they're all forms of multiplication, expressions of multiplication. Okay. So how does multiplication work with those things? So looking down here, we have positive 2. Let me get my pen here. Positive 2 and a positive 3. If we have the product of 2 positive factors, the answer is positive. If we have a negative and a negative, the product of 2 negatives is positive. If we have a negative and a positive, the product of a negative and a positive is going to be negative. Now I have a little diagram that I use that kind of helps describe that. I'm being kind of a visual learner myself. This is the way it works for me. So what I do something like this. What I say is like this. I say, we have a positive number multiplied by a positive number. The answer is positive. If I have a negative number multiplied by a negative number, the answer is positive. But if I have a positive number multiplied by a negative number, the answer is negative. If I have a negative number multiplied by a positive number, the answer is still negative. So let's just take that and simplify it a little bit, even more. What I'm going to show you is that if the signs are the same, positive, positive, or negative, negative, the answer will always be positive. If the signs are different, like negative positive, or say positive negative or negative positive, the answers will be negative. So the signs are the same, the answer is positive. Signs are different, the answer is negative. That's just simply the way I use to describe multiplication of positive and negative integers. And if you have a better way that works for you, that by all means use, but that works well for me, so I'm quite happy with it. So that's how it works. So let's do some examples with positive, negative integers multiplication, and it looks like this right here. I'm going to make this a little larger. So, look at the first one. We have -9 multiplied by 6. So, if you want to use a calculator for this, you can. I'm going to show you how this works in the calculator because it's important to know how to input these numbers in. So, it looks like this. If I'm using my calculator, to use the -9 button, one second. I don't use this button. I'm clear that. I don't use this button. See what's happening. I use this button. So let me sure. Some calculators, the button looks like this. Button looks like this. One second. Like this. And it has a plus and a minus in it. And that's the button you would use. This calculator just has the minus button right here, and that's for the negative number. So if I was going to do the first question, I would go this button here, -9. It's 9. Now you can either go multiply, or you can go back and put a bracket in there, and 6. So it looks exactly the same. And you hit enter, and you see that it's -54. Because the signs are different, the answer is going to be negative. Okay, the next one, you have 7 times 3, and basically they're both positive, so it's 21. Here you see that we used a dot instead of multiplication sign, so it's going to be 8, which don't forget we use this button right here, -8. This time we can go 25 times 14 equals, and it's going to be a negative number because the signs are different. We have a negative here, and we understand that it's a positive there. So it's going to be -112. The next one we have -15 in brackets, so we can still use it over here. We can still go 4 brackets. Remember, we use this negative down here, and this one here. Now you can see the difference in the screen, what it looks like. Do not use the blue one, we use the one down here. So, negative 4 multiplied by, 5, my bad, 5 brackets, -15, close brackets, and that will equal -75, because we have a plus right here. And the minus, the signs are different, which gives us a -75. So down here they're trying to confuse you even more because they're using brackets and the blue dot feature, but it's all still multiply. So I'm going to take a little more time with that one to show you how it works a little bit. So I'm going to do the first part first. What I mean by that, I'm going to do these two numbers first, and then do the remainder at the end. So I'm going to just take my -5 brackets 23 close brackets. Now I'll find out what that number is. And it's going to be a negative number because the signs are opposite. We have a plus right here, an imaginary plus right there, and then -5. So the answer is going to be -115. So down here I'm going to have -115 multiplied by 2. And you see we still have two numbers here right now. So that number multiplied by 2 equals -230. And if you don't want to do it that way, and you have a calculator like mine, you can just do it like this. You can just go -5 brackets 23 close brackets times 2, and it will still give you -230. Depends on the calculator you're using and how much you like using that calculator. Alright, hopefully that's helpful. Basically the rule is that the signs are the same. The answer is positive. The signs are not the same. The answer is negative. Any more questions on this, feel free to ask me in class or send me an email. Awesome. Division of integers kind of works exactly the same way. See right here we have two positives, 20 8 divided by 7, but here we have 128 divided by 4. So we have a positive on top, negative on the bottom, which means we're going to get a negative solution. Looking down here, you can see on our chart, we have 108 divided by positive 3. They're both positive. So the product, which is doesn't be the right word, of two positive integers is positive. So what it's trying to say, because product typically usually means multiplication, if we divide two positive numbers, the answer is positive. If we divide two negative numbers, the answer is still positive. But if we divide a negative and a positive, the answer is negative. So what I'm trying to say, division of integers works exactly the same way as it does for multiplication. If we're dividing integers with the same sign, either be plus or minus, the answer will be positive. If we're dividing integers where one or the other is negative, one or the other being positive, in other words, signs are different, the answer will be negative. So let's look at a few examples of those, so we can try to hammer it home a little bit. Right here, make that a little larger. And hopefully with a few examples, let's see that it makes it a little bit easier to understand. So, if we have 300 divided by 25, there's no sign by 25, but because there's no sign, we automatically assume that it's going to be positive. So 300 divided by 25, and we get an answer of 12. 12 is good. And the answer is positive because it's positive divided by positive. Now the next one, 63 divided by negative 9. 63 is positive. And if you want to use it in your calculator, you just need to go 63 divided by, but don't forget your negative down here, 9, not the negative over here. And the answer should be negative because we have a positive and a negative sign dividing, and we get negative 7. Next one we have, it gives us the signs. We have plus 164 divided by negative 2. So we know the signs are different. By different I mean plus and minus, and they're like that. So 164 divided by negative 2, we're going to have a negative number. And it's going to be 82. And in your calculator you can just go 164, back up, 4 divided by negative 2. That should be divided by, my bad. And that gives us negative 82. The bottom one here is a good example where both signs are the same, but they're negative. So we have negative 14 divided by negative 2, which gives us a positive 7. And in your calculator, you want to try it. We have negative 14 divided by negative 2, and you see we get a positive 7. And that's how it goes. It's available the same rules as if you were using multiplication. The signs are the same, the answer is positive. Signs are opposite, the answer is negative. The last example we have negative 19. Negative 19 divided by 15. That gives us negative 6. It's going to be negative because 15 is positive and 19 is negative. Signs are opposite. So we get a negative number. Good. So every time we go through addition, subtraction, multiplication, division of positive and negative integers, everybody remembers the multiplication division rule because it's pretty easy. Signs are the same, positive, signs are different, it's negative. But don't confuse the rules for multiplication and division with addition and subtraction. So if you need to review the addition and subtraction rules, have a look back at your notes and see those rules. They're different than multiplication and division, and try not to confuse them. Awesome. So right now we're going to move on to the next section. Next section is exponents. And I'm just going to introduce those because after exponents we have order operations, which is a large topic, and I'm not going to get into it right now, but we're going to do some exponential notation and then we'll call it a day. So exponential notation is useful means of writing a product of many factors. The base is the number being multiplied, and the exponent is the number of times the base is being multiplied. Now, I love reading those things out because it sounds like, what? Like, I don't know what that means. You know what that means? Who knows what that means? It means nothing. What they're trying to say is that if we're multiplying 3, for example, 3 times 3 times 3 times 3 times 3, okay? Well, how many 3's do we have? We have 5 3's. 1, 2, 3, 4, 5. So the exponential form would be 3 with the 5 on top. So it looks like this. 3 with the 5. Now that means 3 times 3 times 3 times 3 times 3. Okay? It does not mean this. Most common mistake I see is that 3 to the power of 5. People tend to want to do this. Multiply these two numbers together. Have an answer of 15. That is wrong. Do not do that, please. Let me hit the number up here. Number up here. I'm going to use a different color. The number up here just means the number of 3's we have multiplied by each other. That's it. There's a couple of forms we have. We have the exponential form. Exponential form looks like this. 3 to the power of 5. Factor form, it looks like this. All numbers multiplied by each other. And standard form is the actual combining the 3 times 3 times 3 times 3 times 3 and gives you the final solution of 243. And that's the 3 forms. I'm not sure we get into the order of operations involving exponents, so I'll have a look at that next time. But right now, just worry about, the forms that they can be displayed in. It'll be great. So let's have a look at some stuff down here. Some rules you have to understand. These are very big rules. These are very important rules. And I'm sorry to say, you need to know these. These have to be memorized. You know how much I try not to resort to memorization, but sometimes, you gotta memorize some things. So these are one of the times when you gotta memorize something. But they're not that bad at all. For example, if we have 7 to the power of 1, that means it's 7. So any number raised to the power of 1 is that number. No worries. And if you have a number with no exponent, the exponent is considered to be 1. If you have a number raised to the second power, you can see right here, we say that number is squared, and it's read as 5 squared. If you have a number raised to the third power, we write it like this, 4 to the power of 3, and we say the number is cubed. Any number except 0 raised to the power of 0 equals 1. So it doesn't matter if it's 9 to the power of 0, it's just 1. 121 to the power of 0, it's 1. Any number to the power of 0 is 1, except for 0. So these are some rules you have to know explicitly, because you'll see them from time to time, and especially the square root one here, because one of the square here, because in the second one, the square roots, which is the opposite. You'll be able to be familiar with that. I'm good to go with the square and square root. Okay. You have to memorize those without a doubt. Let's have a look at here at some examples. So if I see right here I have 5 to the power of 3, that means that I have 5 times 5 times 5, which gives me 125. If my math is good in my head right now. Here you can see that I have 10, 10, 10, and 10, which gives me this 10. How many 10s do I have? I have 4 10s, so 10 to the power of 4, and that should be 1,000. This one can be a little different, 16. So there's a number of ways I can do that, and I'm going to show you. I want to show you what I mean by that. So let's take 16. I'm going to do it down here. So I have 16. This is going to be number 1. That's it, number 1. So 16, I can write it in factor form, like this. I can go In factor form, I can go 4 times 4, and in exponential form, I can go 4 squared. Not a problem. However, 16 being a little funny, you can also do this. 16 looks like this. 16. So I can go 2 times 2 is 4, times 2 is 8, times 2 is 16. Same answer, same numbers, it's now I'm just representing them with 2's. And then this time the exponential notation would look like this. 2 to the power of 4. And they're both equally correct, just two different ways of showing it. So I want to take a second to explain that because I don't want you to get too confused about it. The next one here we have 1, 2, 3, 4, 5, 6 2's. So we have 2 to the power of 6. And 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Over here we have 64. 7 squared means we have 7 times 7, which gives us 49. Perfect. So that's exponential notation, squaring and cubing. Actually more than squaring and cubing, but we're going to be focused probably mostly on squaring and cubing. If you have any more questions, don't hesitate to ask or email these days. Moving on a little bit, we see the next section is square roots. Square root, not to put trouble with understanding square roots, but just think of the square root as being the opposite of the square. So if I have 5 squared giving me 25, the square root of 25 is 5. So reading how they say it here, the square root sign is written like this. How to find the square root of a number, one finds the factor that when multiplied by itself equals the number inside the square root. For example, it says, what's the square root of 100? Well, we say 10 multiplied by itself equals 100. So the square root of 100 is just 10. What? So basically, if I want to give you some quick examples here, if I were to say like, I'm going to write this down very simply, very basic. The square root 25 basically means it's going to have the square root 5 times 5, which is 25. So just basically write it down once. Then the square root of 16. Two numbers multiply by itself to give 16. 4 times 4. And write it down once. And that's the square root. It's 4 times 4 is 16. 5 times. So it goes on like that. If I had the square root of 9, square root of 9, two numbers that multiply to give me the square root, two numbers that multiply to give me 9 would be 3 and 3. So the square root of 9 would be 3. So we're looking for square root. We're looking for a number that will multiply by itself equals the value of what's under the square root sign. Hopefully that makes sense. Awesome. Sounds great. Alright, so let's do a couple of examples of that. Here, I think I just did some of these actually. But in any case, you'll see what I mean. I'll break them down like I just did a second ago. Make this a bit larger so we can see what's happening here. So you don't need to go through the whole process that I want to show you here. You just sort of memorize it. You know that 4 times 4 is 16, so the square root of 16 is 4. Or if you want to see it worked out a little better than that, you can just go, okay, I remember that. This means square root 4 times 4, which actually is the square root would be 4. Here, you know that this is the same as 6 times 6, so the square root of 36 is 6. And so on. Square root of 81, 9 times 9, so the square root of 81 is 9. And if you don't want to go through all that process, you can just go square root of 225, it's going to be 15. And the square root of 121 will be 11. So that kind of does squares and square roots. You should review those, make sure you're really familiar and comfortable with those. That'll be great. And the next section we're going to talk about next class will be order of operations. But I want you to get these sign numbers down, because when we get into order of operations and sign numbers get thrown at you, it gets pretty spooky pretty fast. So make sure you have a good grasp on sign numbers, adding, subtracting sign numbers, multiplying, dividing sign numbers, and then we'll make sure you understand what's happening with exponents and square roots and things. Okay, great. We'll call it a day now, and I will see you guys next week. Have a great weekend.